So in this case, ADF is a tangent to the circle at D, with E, B, C, and D points lying on the circumference of a circle. AB is parallel to DC, and EC is equal to DC. If it is given that the size of angle CDF is equal to X, name with reasons 5 other angles that are each equal to X. And this is for 10 marks. So before we can say what, we need to identify all the theorems that we see and everything else which is not a theorem that can actually assist us. So if we give this diagram a good look, we can see that BCDE is a cyclic quadrilateral. So we know that the opposite angles of a cyclic quad are supplementary. And we can also see that angle E1 is an exterior angle of a cyclic quad, and this is equal to the opposite interior angle, over and out. So we see parallel lines, we identify an F shape, so we know that the corresponding angles are equal. Awesome. On the very same concept of parallel lines, we can see that we have alternating angles there because we see a Z shape. And we also know that if lines are parallel, then the sum of these two angles will be 180 degrees because they're co-interior. The sum of these two angles is also 180 degrees because they're co-interior as well. And we can see that since it is given that EC is equal to DC, so this is an isosceles triangle, and we know that these two angles are equal because they are angles opposite equal sides, or they are base angles of an isosceles triangle, if you like. And we can also see that the angle between a tangent to a circle and a chord is equal to the angle in the alternate segment. Well, the same is also true for these two parts. It's the tan-chord theorem. I think that's all we can see, right? Or at least that's all I can see. Right, so now we can go ahead and destroy this question. So we can begin by saying angle E2 is equal to angle CDF, which is equal to X because of the tan-chord theorem. So we come to the diagram, we label it as such. Awesome. And then we say, well, angle E2 is actually equal to angle D2 because they are angles opposite equal sides. Do you see that? Right. Then from this point, what do we say? Well, we identified a Z shape, remember? So we can say angle E1 is equal to angle D2, which is equal to X, because they are alternate angles. Why do they alternate? Well, that's because AB is parallel to DC. And then we can also tell them that angle A is equal to angle CDF, which is equal to X. Why is this one equal to that? You remember the F shape. It's because they are corresponding angles. Why do they correspond? Well, that's because AB is parallel to CD, or DC if you like. And then we identified an exterior angle of a cyclic quad. We said it is equal to the interior opposite angle. So you can say, well, angle E1 is equal to angle C1 plus C2. But if you don't want to write it like this, you can choose to call it angle BCD. That's a nice way of naming it, BCD. So we know that it's this whole angle. Do you see that? Of course, you have to say it's equal to X because angle E1 is an exterior angle of a cyclic quad. So these are the 5 other angles with reasons that are each equal to X. Are we fine? So it's over and out with this one. So now we can go to the next question. This one is asking us to prove that ABCD is a parallelogram. So how can we prove that something is a parallelogram? Well, we need to highlight the quadrilateral we are talking about. So this is the one. I want you to realize that it's already given to us that AB is parallel to DC, right? So we just need to prove that AD is parallel to BC. Because we know that if it's a parallelogram, then 2 pairs of opposite sides are parallel, right? So that's what we need to do. So the question is, how can we prove that AD is parallel to BC? Well, either we can prove that corresponding angles, alternate angles, and co-interior angles, or co-interior angles are not equal, but they are supplementary. So yeah, so that's what we need to do. But the easiest thing we can do is to prove that the co-interior angles are supplementary. That's the easiest we can do. So since we know the size of angle A, which is X, we can just determine the size of angle B. How can we find the size of angle B? Well, we said this is a cyclic quadrilateral. And we know that opposite angles of a cyclic quad are supplementary. In other words, if I take D2, I add it to angle B, I'm just going to get 180 degrees. Right. But now I know that the size of angle D2 is X. I'm looking for the size of angle B, but everything is equal to 180. So this means if I make B the subject of the formula, I'm just going to transpose my X to the right-hand side. So the size of angle B is 180 degrees minus X. Great stuff. So now that we know the size of B, we show them what is going to happen if we add angle A to angle B. So we say the size of angle A is X. The size of angle B is 180 degrees minus X. Collecting the like terms, we see that the X's commit suicide. So we are left with 180 degrees. So what is our conclusion then? Well, we say, therefore, AD is parallel to BC. Why is AD parallel to BC? It's because co-interior angles are supplementary. Or you can say they add up to 180 degrees. So you have shown that this one is parallel to that. And it was given that AB is parallel to DC. Or you can actually write this down and say, since AB is parallel to DC, which was given to us, then we can conclude and say ABCD is a parallelogram. Why do we say it's a parallelogram? Well, it's because two pairs of opposite sides are actually parallel. And then your happiness is complete. Oh, just in case you are surprised about this size, this one means therefore or thus, but this one means since or because. Are we fine? Yes. So that's the difference between the two. But thank you so much for watching. I really hope this video helps a lot.